Hi guys, in this video let's look at a IR practice problem set. It's like page 33 in the workbook. This is a set from the workbook. The answers are in the workbook, the answer key. But the answer key is, I believe, just going to give you the answer to each one. I'm going to go through here illustrate how to arrive at the answer. So let's do some of these problems here together. Okay, we have four IRs. We have a collection of compounds at the top. We need to identify, first off we have directions. Assign one of the compounds below to each spectrum. Not all compounds will be used. Of course, remember to always use your entire knowledge of IR. Okay, this would be the individual IR peaks listed, numbers. Sometimes the copy is going to be small, but you need to become familiar with your standard baseline, usually like 4,000 to 500 reciprocal centimeters. That's 3,000 right there. Okay, of course we have the magic line at 3,000. We can maybe draw that in. You probably want to be using pencil. Is that to the right of 3,000 there? It's hard to know. Let's look over here. Look right here. There's no peaks above 3,000. Okay, or it would be listed there. So if we draw this line here, depends on if the ruler's straight or not. Looks like right there. And those peaks are on the right of 3,000. That line is pretty magical there. To the right of 3,000, what are these peaks for? This is sp3ch. Okay? Where the carbon is sp3 hybridized. It's CH bonds giving rise to these peaks, but the carbon is sp3. Not much over here. We've got this strong peak here at about, okay, 2,000, 1,500, 16, 17 something. If we look over here, 1739. It's the only peak in the 17 region. The 4 is the intensity. This is 100. It's going to come down to 0. The more it comes down, the smaller the number gets. This comes down to 4. It's almost to the bottom, which would be listed as 0. If it came down halfway, that would be 50. Okay. So what is this peak at about 1739? We'll put that here. Well, that's classical carbonyl region. Okay. Carbonyl. Now, of course, lots of functional groups contain a carbonyl. Carbonyl tends to be one of the strongest peaks in an IR when it's present. For example, look down here. Okay, nice carbonyl peak. We'll get to that. The remainder is fingerprint, about 1,500 down fingerprint. Okay, so really you've got two main things here in the non-fingerprint region. That's it. Anything over here in the OH or NH region, very small little peak there, probably nothing, meaningless. Let's see. Do we have a compound that it has only sp3ch? Because this compound does not have sp2ch. No sp2ch. That would be just above 3,000. Not present. Is there a compound up here that has only sp3ch and a carbonyl? Let's look. The first spectrum, not this, because this compound has sp2ch bonds. That's not the answer because this has an NH. An NH is going to give a peak about 3,400. There's no peak here. How about this? All the CH bonds are sp3ch, and it has a carbonyl. That could be the answer. This is not the answer because we've got this aromatic ring. and thus it contains sp2ch bonds. There's none present here. sp3ch, carbonyl, could be it. These two are similar. They're both only sp3ch. They both contain a carbonyl. Obviously this one contains a chlorine, but the carbon-chlorine bond is going to be fingerprint. It's a single bond that does not involve an H, so it should be fingerprint. Let's come back. B and C here both look like possibilities. G. G has 2 carbonyls. This compound should give 2 carbonyl peaks in the IR. Indeed, if you look, this is an anhydride. Anhydride. That's not on our functional group list, but you will see those in organic too. An anhydride, because it has 2 carbonyls in the structure, will give 2 carbonyl peaks in the IR. There's only 1 carbonyl peak. Obviously, H is not the answer because that does not contain a carbonyl. D is not the answer because the IR spectrum does not have any NH peaks. B and C are your only possible answers. Position of carbonyl can help distinguish between B and C. An acid chloride has a high carbonyl. Okay? Up about 1800. I'm going to get the IR list so I can show that. If we look at our table here, okay, in the handout, carbonyl, different carbonyls. The acid chloride is right here. Okay, it's condensed. Acid chlorides have high carbonyls. All right. The exact positioning here of the carbonyls can be very helpful. Ester, which is this one, lower carbonyl, okay, lower down, closer to 1700, and ester tends to be a little high, but not as high as the acid chloride. Of course, that's an anhydride, 2 carbonyls. Your aldehydes and ketones tend to be sort of mid-range, just above 1700, and then your amides tend to have low carbonyls. Okay, this is a sort of mid-range to touch high carbonyl. That tells me that it's an ester. Saturated CH only. Okay, we can call that just saturated CH. And carbonyl. The answer is B. Right there. No other compound matches. Let's do the next one. Nice carbonyl here at about 15, 16, 17, 1800. This is carbonyl here. Now, based on our discussion just there, a carbonyl peak at 1800 indicates what? Acid chloride, typically. Then we can look at the magical 3000. And we see that we have the sp3ch, and again, no sp2ch. Fingerprint. What is this here? What is this here? Well, the carbonyl tells us it has to be an acid chloride. That tells us the answer is C. Okay, the answer is C. This is OH or NH region. There's no NH or NH. Maybe you think this is a OH. Well, the only answer that has an OH is the carboxylic acid. But that looks nothing like the OH of a carboxylic acid. The OH of a carboxylic acid is quite broad. You should look back. We went through every example, every functional group in the other IR videos. Could it be an NH? Okay. The only compound that has just one NH, because there's only one peak, is this one. But it's not E. The answer is not E, mainly because that's an amide, and an amide carbonyl is going to be, okay, amide carbonyls. These are your amides condensed down. Make sure you understand these condensed drawings, structures. Amide carbonyl is mid-1600s. That is not an amide carbonyl. The answer is C. What is this? This is probably an overtone. We talked about this in the other IR videos. A lot of time an intense peak will give an overtone at double the value minus a touch. 18 times 2 is 3600 minus a touch. This peak is, I think that's a 5. 3580. Okay? That's double minus a touch. That's a good indicator that that's an overtone. All right? And it's not a actual structural component or a peak that comes from a structural component. It's really the carbonyl that's causing this. We call it an overtone or second harmonic. Up here, you see the difference? This peak is more intense. It's wider, more absorbance going on. The more intense the peak here, the more likely it is to have an overtone. Up here, that may have been an overtone, but it was so small I just sort of ignored it. Okay, we got B and C. Third one here. Ooh, pretty busy through here. By the way, these two up here were not as busy through here at sort of the 1700 region, sort of flat. Okay, 2000. If you remember that through here is sort of the aromatic signature, especially here, but also an aromatic is going to have peaks at about 1600. These do not look aromatic, and indeed they're not. This looks very aromatic to me. Aromatic signature, sort of multiple peaks at 15, 1600, sort of looks aromatic. These peaks over here are coming from the aromatic carbon-carbon double bonds. No carbonyl. Okay, a carbonyl is going to be intense. It's not that. That's not a carbonyl. That's probably an aryl carbon-carbon double bond. Magic line of 3000. It looks like this peak here, which I covered with my pen, is above 3000. Indeed, if we look here, we got peaks just above 3000. There's nothing at 29. The next peak is 2256, which we can say here. That peak appears to be above 3000, so it's sp2ch. And no sp3ch. But what is this strong peak at 2256? So you should know that this region is your triple bond region, either C triple bond N or C triple bond C. Okay, 2200 region. Now if we look up here, you're only going to see one compound with a C triple bond, and that is this one here, C triple bond N. So we know that that's clearly not a C triple bond C. If it was, then we have no choice. So that's a little test-taking strategy. We don't have to decide between these two. We let the choice of the answers tell us it can't be this, must be that, and that's your answer. Thus, we've got the peak for the cyano group, or the nitrile, here. This is your CN. We've got aromatic signature here, coming from the aromatic ring. I'm sorry, here, can't see there. Up here. Cyano group, aromatic signature. And of course, there are sp2ch bonds here. There's 5 of them. Each of the other carbons has a H. And so there are many sp2ch's. There's 5 of them. Of course, just because there are 5 of them does not mean we're going to get 5 peaks. You can't really do that with your CH peaks. You can't quantify with your CH peaks like that. And the answer is H. No other compound fits. It's not F because F has a carbonyl. There's no carbonyl in this IR. This compound would not give a peak at about 2200. There's no carbon-carbon triple bond or carbon-nitrogen triple bond. It's just not F. The answer is H there. Last one here, 4A. Let's see. It looks like with this one, now I messed up and drew my line a little to the left. That line should be a little bit more to the right. I think we have sp3ch, but we also have sp2ch. Because if you look at your peak values here, we have a peak just below 3000. We also have a couple of peaks just above 3,000, which are these 2 right there, which I drew my line straight through. Okay? So in this case, we have 2 types of CH bonds. This looks like a carbonyl to me. Not as easily to recognize as the first 2. But this peak is 16 something, 1633. It's a low carbonyl. I'm calling it a carbonyl because it's pretty intense. It's a little wide, okay? Where this one here was real narrow and not as intense. That does not look like a carbonyl. This does. Low carbonyl though. What does that tell us? What type of functional group would have a low carbonyl? Most likely amide, okay? Especially that low. Something in the 16, 60, 70, 80 range may not be an amide. Looks like an amide with both types of hydrogens, sp2 and sp3ch. None of these examples had an SPCH, which would be about 3300. What is this here? Doesn't really look like an NH. The NH of an amide is going to be fairly strong and intense. Look at the examples in the packet. Amide, NH. Right here in the handout, amide, the NH of an amide. Look how intense it was. Okay, here this was a primary amide, 2 peaks, 2 strong. All right, tertiary amide, no NH. We expect no peak, but we got this little something here. That could be overtone, but it looks a little broad. It actually could be water. These could be real spectra. Maybe a little moisture. But it's not an intense peak. This is even weaker. I don't think that's a peak. It's a little water or overtone. Although overtone would be double minus a touch. That's 3266 minus a touch. That's higher than that. Don't let that confuse you. That is not an amide NH. Let's keep it open though. What could be our choices? I'm pretty confident it's an amide, carbonyl. That means we're looking at E, F, or D. Well, F has an aromatic, benzene ring. Does this look aromatic? Kind of does. It's kind of weak, but it's like a mountain range here. Look at the difference between this sort of mountain range and up here, very top. Much smoother up here, flatter. Also, but this is the kicker. This is the most important. We've got sp2ch. And if you look at the three amides, boom, boom, and boom, only F has sp2ch. D and E does not have sp2ch. All the CH bonds in D and E are sp3ch. Looks like an aromatic. We've also got peaks at sort of the 15, okay? Sort of in here, in this mountain range, looks like aromatic. We've got the sp2ch, which sort of confirms it's aromatic. It doesn't really confirm it, but only if you're looking at something like that. In this case, with these choices, it confirms it's aromatic. I'm pretty confident that this one is F. Yes, F. We might circle these to make them stand out a little better. Or you could use an arrow and sort of some clear indication of what your answers are. Okay, guys, so that's me working one of the problem sets in the workbook. Please be giving the other problem sets a try. But that's the basic approach that I recommend taking to working these IR problems. Okay, guys.